Good morning, guys. Today we're going to be looking at rational exponents. This will be part one of a three-part set of notes. What we're going to be working on or focusing on is being able to understand a rational exponent and then being able to convert it between exponential form and radical form using this kind of a transformation formula. And also we want to be able to simplify these expressions that have rational exponents. Okay, so the expression that we're working with is if you have something to the power of a fraction, you can rewrite this fraction into kind of a square root form. And so an example of this, and we've worked with something like this already. For example, when we were working with square roots and cube roots, we had something like this. We had x to the power of 1/2 converts to or is equal to the square root of x. And then if I have something like x to the power of 1/3, we said that that converts to the cube root of x. And so we've seen this already, right? We said, even though there's no 2 in front, there's assumed to be a 2 in front of this square root, and x is has the power of 1. This x in here has the power of 1. So that's where this conversion form comes from. I have 1 divided by 2, and I can rewrite it in this form, right? Where the denominator goes in front of the root symbol, and the numerator goes inside of the square root or the cube root, whatever the root is. And another way to write this form, the square root form, is you can also put the exponent that's inside, you can put it outside. And sometimes the problem has it outside, like it has it in one of these two forms, and we have to be able to know that these two forms can be rewritten into this form. Okay, so we're going to practice this, and I think it'll make sense after we do a couple of examples. But this is the best example that we've had so far. When we had x to the power of 1/2 and x to the power of 1/3, we would convert those to square roots and cube roots. Okay, so let's go ahead and jump into the examples. All right, so let's look at, I guess we'll do them in sets of 3 since they're right here. Okay, so example 1, and the directions just say, write each algebraic expression in radical form. And you know what? Let me keep that in view. Okay, so first off we have x to the power 1/2, which if we use this rule here, all we're saying is that x to the 1/2 power becomes, we can put the denominator in front of the root, but we should know that this just converts to the square root of x. Okay, and usually there's a 2 in front here, but we usually don't write it in when we're talking about square roots. If you just write the square root symbol, everybody kind of knows that it's already called the square root. Okay, so this is the answer to the first one. Then the second one, here what we want to notice, or we should notice, is that the exponent is only a part of of the letter z. It's not a part of the 6. So only the z is going to be transformed. Okay. And the rule is, so all we're going to do is bring over the 6, copy the 6, and the z is going to be transformed. So it's going to have a root, it's going to have a z, and then we have to decide, where do these numbers go? The 3 and the 4. Okay, using this model here. So the 3, it's the number on top, the m in this case, is going to go inside. So the top number goes inside. So it's z to the power of 3 inside. And then the bottom number, the 4, in this case the n, goes in front of the root. Something like that. And there we have it. That's our answer there. So again, the top number, the 3, goes inside. So it's z to the power of 3. And then the bottom number goes outside of the root, in front of the root. Okay. Now, in this case, the fraction exponent is covering the 10 and the a. Remember in number 2, the exponent was only covering the z. This time it's covering both of them. So both the 10 and the a are going to go inside the root. So let me just write it again down here. And so this is equal to, again, we're going to write the root. And then it's going to be 10a is inside the root. And then we have to decide, where does the 7 and the 2 go? So remember, the top number goes inside. Top number goes inside. And the bottom number goes in the front. So the top number, the 7, goes inside, and the bottom number goes in the front. And if the number in front is a 2, we don't have to write the 2, so we can just write it as the square root of 10a to the power of 7. And covering it. There we go. That's what we could do. Okay. So just continuing to practice this pattern. So let's try the pattern again. Let's keep going. All right. So here we have y to the negative 2/3. So now we have a negative exponent, and we're going to use some of the rules that we used in the previous notes. What do we do with negative exponents? And so, copy it over here. We have y to the negative 2/3. But using the rules from the last notes, we can rewrite this as y to the positive 2/3, 1 over y to the positive 2/3. Rewrite that 3 there. Okay. And then we can do one more thing with what we learned today. We're going to do 1 over then the root symbol, and the y is going to go inside. Then we have to decide, where is the 2 and the 3 going to go? So remember, the 2 on the number on top, the fraction, the 2 goes inside. So it's going to be y squared inside, and the 3 goes in front. Actually, let me rewrite that again. Okay, so again, we have a negative exponent, so we're using the rules of negative exponents from last class and moving it to the bottom. Then we're rewriting this fraction exponent into radical form, because the instructions say write each algebraic expression in radical form. So radical form is having this root symbol. This is a radical. Example 5, the negative 1/3 is only on the m. Okay, so if they don't have a parentheses, then we assume that it only belongs to the letter closest to it, to the number of the letter closest to it. Over here in number 3, we knew that it was on both because there was a parentheses covering both. Here there's no parentheses, so we assume that the negative 1/3 is a power of m. So the negative 3 is by itself. So we're going to have negative 3, then we're going to put the root symbol. Oh, sorry. Negative 3, let me just copy it again. Okay. So what we can do there is we could rewrite it as negative 3 on top, and on the bottom we're going to write m to the power of 1/3, because we're just using the rule that we can move this term here to the bottom, right? Because we assume that there's a 1 underneath, and so we can move this term to the bottom, but the negative 3 stays on top. The negative 3 stays on top, and so I have 1/3 on the bottom, and so we can rewrite it as negative 3 on top divided by the root symbol. And remember, something to the 1/3 is a cube root, so it just has the 3 in front, and there's usually a 1. The top number goes inside, right? But m to the power of 1 is just m. So we don't have to write the power of 1 here. And so that is our answer for example 5. Now for example 6, notice that the 8 and the n are both inside the parentheses. And notice that the power is negative, so we have to convert it first. So let me copy the problem. Convert this to a negative. So we're going to do 1 over 8n to the power of the positive fraction. So it's going to be a positive 5/2. Positive 5/2. And then we can use the rule of today. We're going to copy the 1 and put the division sign. And then we're going to do the root symbol. Put the 8n in there. And what's going to go inside? Remember, the top number goes inside and the bottom number goes outside. So the bottom number is going to go outside and the top number is going to go inside. But then we can rewrite it, or yeah, you can actually rewrite it, but what's up to you actually. Let's keep it with a square root this time in front. But you can write it without the 2 or with the 2. But if we write it without the 2, we would write 8n to the power of 5, and there's a square root. So we can write it that way too. And that would be our answer there. Zoom out there. All right, so those are the 6 problems that we did. Then let's go on to the next examples. On the next page we have example 7. Now we're going to go in the opposite direction. Okay, so we're going to go from radical form So writing algebraic expressions with radical form, but then we're going to change it into a fractional exponent. So we're going to go backwards in a way. Okay, so let's look at this first one, for example. Yeah, so let me copy it. Okay, so I would rewrite this, and let me write, where do I want to write the rule? I guess I'll write it on top just so that we remember. I don't remember if the colors are correct. It was something like this. So we say that this is equal to n with the root symbol and the variable to the power of m. Okay, so I'm just writing the rule back up here so we can have it kind of as a reference. So now we were working with problems like this in the first 6 examples, and then we were changing them from this version to the radical version. Now we're going backwards. Now we want to go from this form to this form. Okay, so how do I go back to that form? So we're going to write the variable, and then we're going to write a fraction with the numbers that are in the front and inside. So it's the number inside divided by the one outside. It's the number inside divided by the one in front. So it's going to be m to the power of 2 is the number inside over 3. Okay, so it's the number inside divided by the number outside. Okay, let's look at the next one. Here what we want to notice is that the negative 2 is not the number in front. The number in front of the root is 4. And inside here we have multiple variables with different exponents. So what we can do is we can kind of separate them, but let's rewrite it and see what happens. So I'm just going to write it again. Right, now that we have it like that, then we can say, okay, the negative 2 is just going to come over, and then we have x and y. And we want to change it from radical form to fraction exponents. So it's the number inside divided by the one outside. So it's 7. The x has a 7 over 4, and the y has a 3 over 4. That's it for that one. So, but actually, let me write it again because I want to make sure there's space. So I'm going to write it underneath actually, so that I know that there's going to be space. So it's negative 2 x to the power of 7 divided by the number in front. So x to the power of 7. So x to the power of the one inside. But the fraction is going to be 7 divided by 4, because 4 is the number in front. So it's 7 divided by 4 times y to the power of 3 divided by 4. 3 divided by 4. So what happens is, if you have two different variables with different exponents, you can divide these exponents by the number in front. So it's 7 divided by 4 and 3 divided by 4. So it's 7 divided by 4 and 3 divided by 4. And nothing happened with the negative 2. It just comes down to the next step. And so this is our answer for example 8. Then we look at example 9. What we want to keep in mind here is if there's no number in front of the root symbol, then it's assumed to have a 2. Okay, so if it has a 2, then we're going to rewrite it as 8a to the power of the number inside the root, 3, divided by the number outside. So 8a changes to a fraction of 3 over 2. So 3 over 2, 3 over 2. Following, this model again. That's it. Okay. So again, the thing that we wanted to remember in number 9 was if it's not written, then we assume there's a 2 in front. All right. Here we have another assumption again. We have this assumption that if it's not written, then there's a 2 in front. But actually, let me write it again so that I can write it a little bit bigger. So there's a 2 in front here if it's not expressed. And how many x's are inside? It's just x to the power of 1. So it becomes 1 over x to the power of 1/2. And then we want to move this to the top. So we're going to use one of the rules from last class. So if you want to move that to the top up there, that would equal to x to the power of negative 1/2. X to the power of negative 1/2. All right. All right. Number 11. And again, let me write it over here. Oh, 4 square, or the root symbol to the power of 3. Okay. And so bring over the 5. Then we still have n, and we want to change this to a fraction. So it's the number that's the power that's inside. So it's 3 divided by 4. So it's 3 divided by 4. And then we want to move the exponent to the top. It's kind of like we did in example 10 right now. Move it to the top, so we get 5n to the power of negative 3 over 4. And that's the answer for 11. Then for number 12, let me copy that one down. Okay. Number 12 is kind of like number 8, where we had 2 variables and each of them gave me a different fraction, right? Because they had different exponents with the same denominator because the number in front of the root was the same. So here, what we want to make note of is that if a doesn't have a power, then we assume that it's a 1. So what we can do is, bring over the 1 and then divide. And so we have a, if I rewrite the a part as a fraction, it's going to be 1 divided by 3. 1 divided by 3. So it's going to be 1/3. And then if we look at the b part, there's a 4b to the 4 and there's a 3 in front. So it's going to be a fraction of 4 divided by 3. 4 divided by 3. Okay. And then one last thing we can do is we can move both of these to the top. Use a different color for B, but we can move both of them to the top because there's division happening here, but we can move both of them to the top. So it's going to be a to the negative 1/3 times b to the negative 4/3. And that's going to be, it's going to be my final answer there, but I don't want to cross it out. So there we go. Awesome. So that leaves us with example 12. Then we have one more section to look at. That section has, let's see, six more. So it's almost the same number that we did earlier. Okay. So this one is a little bit different than what we've been doing right now. Okay, and so for this one, it requires a little bit of long division. Okay, and so what we want to remember or kind of keep note of is what they're asking us to do in the problem. Okay, and the key thing you want to look for are these words. So if you see the word simplify and write your answers in radical form, this is going to signal you to do the process that we're going to do here today. And the process is called long division. Or you could say, division with remainders. So for this one, I'm going to kind of zoom in to each example so that we can kind of have space to work out things. So let me make sure I'm using all the space there. Okay, so that's a good amount, I guess. So we can do that. Okay. So first thing to note is that we can do the following. If I have the square root of two different types of numbers, I have 36 and y squared. If I have them inside of a root, I can actually separate them into their own roots. So like this. Okay. And then I can kind of simplify or do what they're telling me to do. They're telling me to simplify this radical expression. So if I simplify, then I have, well, the square root of 36 is 6. And the square root of y squared. So the nice thing is, if we change this expression from radical form into fraction form, remember, if there's no number in front of the square roots, then we assume that there's a 2 here, right? So we can rewrite this expression as a fraction. So it's the number inside divided by the number outside. So it's 2 divided by 2. But 2 divided by 2 is 1. So we get y to the power of 1. And so our final answer is just 6y. Okay. So that's example 13. That one didn't require, long division per se, but let's see what will. I think the next one will. All right. So like I said, we have the number 64 and the variable and the power, and you can rewrite this so that they can have their own radical form. So we have 64 and then the cube root of p to the 20. So I can separate them into their own cube roots, and then we can solve each individually. So we want to find what's the cube root of 64. What's the cube root of 64? Well, what number multiplied by itself 3 times is 64? So we can try, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4. So some of these things we would need to know, right? So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. But to get 64, it's actually 4 times 4 times 4. So 4 times 4 times 4 is 64. Okay, so I can rewrite this and say, okay, this is 4 to the power of 3 is 64, right? And then I can write this in fraction form. So I get p to the power of 20 divided by 3. 20 divided by 3. And then over here, I can write that in fraction form. It's 4 to the power of 3 over 3. Just copy the 20 over 3. Okay, and so this is where the long division happens. But first of all, right, 3 divided by 3 is 1. 3 divided by 3 is 1. So this becomes 4. And again, I'm going to copy this p to the power of 20 over 3. Okay, and so this is where the long division starts. And so what we're going to do in long division, and the reason I know that we're going to do long division is if the numerator can be divided by the denominator, if 3 can go into 20, and also if they're asking us to simplify, this is what we're going to do. So we're going to actually divide, and so we're going to say, what is 20? Actually, let me, what do I want to write? Let me erase this. And over here, I'm just going to write what we actually used, right? We used the fact that 4 times 4 times 4 was 64. That's what we used to get this part here. Okay, now let's do long division. So long division, we're going to figure out what's 20 divided by 3. Kind of taking us back to elementary, right? So how many times can 3 go into 20? 6 times. 6 times 3 is 18. Then we subtract 20 minus 18 is 2. And so we would say we have a remainder of 2. We have a remainder of 2. Okay. And so this is what we're going to do. We're going to say, let me pick a different color actually. I'm going to use orange and green. Okay. So this number here and these two numbers are going to work in the following way. We're going to copy the 4, and then we're going to write p to the power of 6 times p to the power of 2/3. Okay, so where did the 6 come from? From the long division, and the 2/3 came from the remainder. Okay, so again, p to the power of 20 over 3, we divided 20 by 3. 3 goes into 26 times, and we get a remainder of 2. And so we're going to write p to the power of 6, p to the power of the whole number that we got when we divided, times p, the same variable, p to the power of 2/3. 2 is the remainder divided by 3. And so that leaves us to the last step. We would write 4p to the power of 6 times, now change p to the 2/3 into a radical form. Okay, so it's p to the power of, the 2 goes inside and the 3 goes in front. So changing the exponential form to radical form. And that is our answer for example 14. And again, we're going to keep practicing this, and after a couple, we're going to get the hang of it. For now, keep track of what we're doing, right? We're dividing 20 by 3, getting a whole number and a remainder. Actually, I think this is called a dividend. And then we get a quotient and a remainder. But whatever we get as our whole number, that's what we're going to put p to the power of. And then we're going to put p to the power of the remainder divided by 3. Okay, so let's jump over to example 15 and see. You can try it again. Okay. So we have here again, we could say we can separate 81 and the 4th root of c to the power of 11. Okay, and then here we're going to ask ourselves, is there a number that I can multiply 4 times by itself to give me 81? And what should come to mind is 3 times 3 times 3 times 3 is 81. So 3, let me write it like this. 3 to the power of 4 is 81. So I'm going to, substitute that over here. So it's going to give me the fourth root of 3 to the power of 4. And then times I can rewrite this as c to the power of 11 over 4. And then this part that I just got right now, I can rewrite it again as a fraction. I can write it as 3 to the power of 4 over 4 times c to the power of 11 over 4. And 4 divided by 4 becomes 1, so it's just 3. Okay. Now let's do the long division. We're going to divide 11 divided by 4. 4 goes into 11 2 times. 4 times 2 is 8. Subtract 11 minus 8 is 3. So the remainder is 3. And so we're going to have 2 is our whole number, and 3 over 4 is our remainder. So we're going to write it, bring down the 3, then write c to the power of 2. And again, the 2 that I'm getting is from over here. And then we're still writing the remainder of the fraction, so we're going to put c again, but we're going to make a fraction out of this remainder, so 3 out of 4, 3 over 4. Okay, and then the last step, copy the 3, copy the c squared. Then the c to the power of 3/4 can be written as in radical form, where we have the square root symbol, we have c, and the numerator goes inside, so the 3 goes inside, and the 4 goes in front. Okay. So now let's go to example 16. Okay, so now there's no number, so we can just, let me just write it again, but we're going to divide 5 by 2, doing the long division. So 5 is going to get divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. So we get a remainder of 1. So the number in front is our whole number, and then we're going to use 1/2 as our fraction. So we're going to have x to the power of 2 times x to the power of 1/2. So again, the 2 comes from the whole number that we got, the number of times that 2 goes into 5. And then the 1/2, this 1/2 here, comes from the remainder. And so we can rewrite this as equals x squared times the square root of x. Okay. Then we're going to go to example 17. And again, we're doing a total of 18 examples, so we're almost done. Okay, here what we want to notice is that the 12 is by itself. Or in other words, it's not being raised to the power of 4/3. Only the z is being raised to the power of 4/3. So we can just bring the 12 along and 4/3. So I'm basically just copying the problem. But what we're going to do is do long division again. So we're going to divide 4 by 3. 3 goes into 4 one time. 1 times 3 is 3. Subtract. 4 minus 3 is 1. So we get a remainder 1. And so this number goes on its own, and 1 and 3 make a fraction. So it's 12 times z to the power of 1 times z to the power of 1/3. So that becomes 12z times the cube root of z. Okay. And then example 18. All right, so now the 8 is part of the problem. Actually, let me zoom out a little bit. There we go. Okay. So for this one, there's really nothing to do because we can't really find, for example, if I wanted to simplify 8, find a number that I multiply 4 times to get 8. If I multiply, 2 times 2 times 2 times 2, that gives me 16. So it doesn't even give me 8. So I can't use the same strategy that I used before. So all we're going to do for this one is just rewrite it in radical form, because also with the 1/4, you can't divide that. You can't do long division, right? If I try and divide 1 divided by 4, 4 cannot fit into 1. Okay, so that's another thing that kind of keeps us from doing what we've been doing. So all we can really do is put the root symbol and put 8mn, and then inside is the power of 1, and in the front is the 4. But 8mn to the power of 1, we can just rewrite it as the 4th root of 8mn. And that's pretty much it. 18. All right. So that brings us to the end of our notes. Again, during class time, we can go over any of these examples if there's anything that you want to clarify. Especially this last section. This is the section that has all this long division to it. But yeah, any questions, feel free to bring them up in class. And thank you for joining me today, guys.